Hello again, algebra students. We are looking right now at page 18, and we are going to get into linear equations today. So everybody right now should be on page 18. This is video number 6, and we're going to start linear equations today. So if we're looking at linear equations, the really important things to know about linear equations are, if you look at the word linear, it says line right in there. So linear equations mean line, and they have a consistent or constant increase or decrease. So if we're talking about linear equations, it just means a line, and they have a constant increase or decrease. So if we take a look at number 1A, it says, at a local farm stand, 6 apples can be bought for $3. How much does it cost to buy 1 apple? So if I'm looking at the cost per apple, my cost is $3 per apple, and I have 6 apples. So if I divided 3 by 6, I would get 50 cents. So it costs 50 cents to buy 1 apple. So now, if I look at B, it says, how much would a dozen apples cost? So we know that a dozen means 12. So if I take 12 and multiply it by 50 cents, we should be getting half of 12, which is $6. I'm going to give you about 10 seconds to go ahead and try part C. It says, how much would 20 apples cost? So right now, you are working on part C. How much would 20 apples cost? And if you said $10, that is correct, because we're taking 20 apples. They cost 50 cents per apple, so that would be $10. You can put the dollar sign, you do not have to, but you can if you want to. All right, then we go to part D, which is the graph. It says, graph the results on the grid below, where C represents the total cost on your y-axis. So my y is to the sky, so y is the up and down axis, the vertical axis. And I'm going to write total cost on there. And N represents the number of apples on your x-axis. So the x-axis is your horizontal axis. It goes left to right. And that's going to be number of apples. So it wants me to graph the results where C represents the total cost on the y-axis and N is the number of apples on your x-axis. So we said that if we have number of apples, I'm just going to count by my whole number. So I'm going to skip a box each time. So I have 0, then I'm going to skip a box 1, skip a box 2, skip a box 3, skip a box 4. I'm going to keep going until I run out of room. So we should be able to get up to 10 apples. And then we said each apple costs 50 cents. So I'm going to do my y-axis, I'm going to count by 0.5. So again, I'm going to skip a box. So if I skip a box in the first y-axis, then I need to skip a box each time on my y-axis. So 0.5, 1, skip a box, then 1.5, skip a box, 2, skip a box, 2.5, skip a box, 3, skip a box, 3.5. We're going to continue that pattern. And you should be able to get up to 5 on the top line of your y-axis. So if I'm graphing this, we said that for every 1 apple, it costs 50 cents. So my point would be at 1 to the right and up to 0.5. Because for 1 apple, it costs 50 cents. So for 2 apples, it would cost $1. For 3 apples, it would cost $1.50. So at this point, you should start to notice that every time your line or your next coordinate or your next point is going up 2 boxes and to the right 2 boxes. So I'm going to continue that pattern. And remember, we're talking about linear functions today, so now we're going to create a line. So if I had 0 apples, it would cost $0. And then I'm just going to connect my coordinates. I'm going to put an arrow up at the top there. So there we created a line, which is a linear function, or a linear equation. Part E says if C is the total cost of apples and N is the number of apples bought, write an equation that could be used to find the cost of any number of apples. So if C is the total cost, we want an equation. So an equation has to have an equal sign. And then we said N is the number of apples bought. We said it was 50 cents for each apple. So your equation would be C, which is the total cost, equals 0.50, and then N for number of apples. If you wanted to write C equals 0.5N, that would be fine as well. You can put the 0 on after the 5 or not. They are the same equation. So now part F says, what do you notice is the relationship between this equation and your graph? So if we notice on our graph, for every one apple, we were going up another 50 cents. And if we look at our equation, we said that for every one apple, no matter how many there are, we're going to have another 50 cents. So the relationship between the equation and the graph is that both increase by 50 cents every time. Right, so again, that was page 18, linear equations. We're now going to skip over to page 20. So go ahead to page 20, please. So we're on page 20, which is number 3. So number 3 says, Hans needs to rent a moving truck to move into his new house. U-Haul charges a rate of $50 up front and $60 per day. Write an algebraic equation for the total cost C based on the number of days D. So they're already starting our equation for us. They said C equals, remember we're doing an equation, so it has to have an equal sign. So it says that they charge $50 up front. So that's going to be my starting cost. So I'm just going to put 50. And then plus, they say $60 per day, and we said that our number of days is represented by D. So now the next part says complete the table and graph the function. So if I want to know how much it's going to cost for 0 days, D, remember, is representing my days. So where the D is in my equation, I'm going to plug in 0 for D, because it's 0 days. And if I type that in my calculator, 60 times 0 is 0, plus 50 would give me 50. So before I even use the U-Haul, I have to pay $50 up front. Up front means ahead of time. So now, if I used it for 1 day, I'm going to plug 1 in where the D was in the equation. So now I have 60 times 1, which would be 60, plus 50, which is 110. So for my first day, I would be paying $110 for the U-Haul. If I had the U-Haul for 2 days, where the D was for the number of days, I'm plugging in 2. So 60 times 2 is 120, plus 50 should give me 170. So at this point, you might be noticing a pattern. So what's happening each time, because we said that our linear equations or our linear functions increase at a constant. So the constant means the same amount. So each time my total cost was going up by 60. And for a linear function, that will continue to happen. So if I increase 170 by 60, I would get 230. If I increase 230 by 60, I would get 290. So now it wanted me to graph. So my graph is missing a couple things you'll notice. I don't have any labels, so let's go ahead and label this. So in my table, whatever came first was X. So that means that my days are my X. And what comes second is your Y. So my total cost goes on my Y-axis. And now we're just going to graph these as coordinates. So on 0 days, I am at $50. So 50 would be right in the middle of 40 and 60. So I didn't go left or right because it was 0 days, and I went up to 50. On my first day, I was at 110, so I'm going 1 to the right and up to 110, which is in the middle of 100 and 120. Then I have 2 and 170, so 2 to the right up to 170, which is in the middle of 160 and 180. Then I have 3 and 230. And then I have 4 and 290. I'm going to connect my dots and an arrow at the top, and we have completed our graph. Actually, we have not completed our graph. We want to make sure that we are labeling this line, this linear function. So we label with the equation. We wrote the equation as C equals 50 plus 60D. Remember, you can pause the video if I'm going too fast. You can rewind the video if you didn't understand something. You can message Miss Santoro or myself if you have any questions. And then we have one more question on page 20. It says, based on your line, how much would it cost to rent a truck for 8 days? Prove your answer is correct algebraically. So algebraically means you need to show work. So if we're looking for 8 days, I'm going to take that same equation, C equals 50 plus 60D, and where D is, I'm going to plug in 8 because D stands for number of days, and we said 8 days. So then we have C equals, if we type this into our calculator, we should get 530. So we have now finished page 20. So what you're going to do on your own is page 19 and page 21. You're going to submit that under video number 6, picture. So again, right now you are working on page 19 and page 21. You are submitting those 2 pages in separate submissions under video number 6. And please message your teacher if you have any questions. Have a great day, everybody.